On the morning of July 4, 1956, a slender aircraft with wings nearly as wide as a DC-3 transport climbed silently into the stratosphere above Wiesbaden Air Base in West Germany. Its pilot, a CIA contractor wearing a full-pressure suit identical to those worn by test pilots approaching the edge of space, checked his oxygen flow, scanned the instrument panel, and pushed the throttle forward one final time. Within minutes, the Lockheed U-2 reached 70,000 feet and crossed into Soviet airspace. Below, through the crystal-clear optics of its downward-facing camera, the pilot watched the sprawl of Leningrad appear in the viewfinder with astonishing clarity. Soviet radar operators stared at their screens and reported an impossible contact. An aircraft flying at an altitude no Soviet interceptor could reach, no surface-to-air missile could engage, and no defense system had been designed to defeat. The United States had built a reconnaissance aircraft that flew above the reach of the Soviet arsenal, and it had just begun photographing the heart of the communist empire. What Soviet commanders dismissed as an American bluff became the most devastating intelligence breakthrough of the Cold War's opening decade. Soviet military leadership in the mid-1950s believed their air defenses were impenetrable. The USSR had stationed thousands of anti-aircraft guns, deployed entire regiments of MiG-17 and MiG-19 interceptors, and fielded early warning radar stations from the Kamchatka Peninsula to the borders of Poland. The SA-2 surface-to-air missile system, developed in secrecy and deployed around critical military installations, represented the most sophisticated anti-aircraft technology in the world. Soviet Air Defense Force commanders confidently asserted that any American reconnaissance attempt would be detected, tracked, and destroyed. General Yevgeny Savitsky, chief of Soviet Air Defense Aviation, declared in internal briefings that American spy flights would face absolute interception. The Soviet General Staff issued tactical directives emphasizing the readiness of both interceptor squadrons and missile batteries. Soviet newspapers and state propaganda celebrated the strength of the nation's air defenses, framing Soviet airspace as inviolable. Intelligence reports flowing to Moscow from KGB assets in the West suggested that the United States had no aircraft capable of sustained flight above 60,000 feet. This assessment, rooted in flawed data and a misunderstanding of American aerospace capabilities, reinforced Soviet confidence. The Kremlin's strategic doctrine rested on the assumption that surveillance of Soviet territory required low-altitude penetration flights, which could be intercepted and destroyed with certainty. Every element of Soviet air defense doctrine, from deployment patterns to training exercises, reflected the belief that the skies above the USSR were under absolute control. Yet no amount of radar coverage, interceptor readiness, or missile positioning could challenge what happened next. The U-2 Dragon Lady emerged from a secretive collaboration between the Central Intelligence Agency and Lockheed's Advanced Development Projects Division, known informally as the Skunk Works. In late 1954, President Dwight Eisenhower approved a classified program designated AQ-A2NE, authorizing Lockheed to develop a reconnaissance aircraft that could fly higher and farther than any Soviet interceptor or missile could reach. Clarence Kelly Johnson, the brilliant aerospace engineer who led Skunk Works, designed an aircraft unlike anything in the American inventory. The U-2 was a powered glider, built with a lightweight aluminum frame, long slender wings spanning 80 feet, and a single Pratt & Whitney J57 turbojet engine that provided just enough thrust to sustain flight at altitudes above 70,000 feet. The aircraft's design prioritized altitude over speed, range over maneuverability, and camera capacity over armament. Johnson and his team engineered a machine so aerodynamically efficient that it could cruise for hours in the thin stratospheric air where human lungs would collapse without pressurization. The U-2's fuselage was narrow, designed to accommodate a single pilot in a specialized pressure suit, extensive camera equipment, and fuel tanks capable of sustaining missions lasting more than 8 hours. Its operational ceiling exceeded the maximum effective altitude of Soviet interceptors by 20,000 feet. The aircraft flew at the edge of controlled flight, where the margin between stalling and structural overstress measured in single-digit knots of airspeed. Pilots referred to this narrow band as the coffin corner, a regime where even the slightest deviation in power or attitude could send the aircraft tumbling out of the sky or tearing itself apart. Yet for reconnaissance missions deep inside enemy territory, the U-2's altitude capability represented an unassailable advantage. Eisenhower's authorization of Project AQ-A2NE in November 1954 reflected growing anxiety within the American intelligence community about Soviet military capabilities. Throughout the early 1950s, the United States possessed limited intelligence on Soviet bomber production, missile development, and nuclear weapons infrastructure. Ground-based intelligence networks inside the Soviet Union had been systematically dismantled by Soviet counterintelligence operations. Diplomatic channels provided no reliable information. High-altitude balloon reconnaissance programs delivered inconsistent results and frequently provoked diplomatic protests when balloons drifted into Soviet airspace and were recovered by Soviet authorities. The intelligence gap created strategic uncertainty that complicated American defense planning and fueled fears of a bomber gap, where Soviet strategic aviation might outnumber American capabilities. Edwin Land, the inventor of Polaroid instant photography and chairman of the Intelligence Committee within Eisenhower's Technological Capabilities Panel, urged development of a high-altitude reconnaissance aircraft capable of photographing Soviet territory from altitudes beyond the reach of Soviet air defenses. Land's proposal emphasized that photographic intelligence collected from extreme altitude could provide verifiable data on Soviet military capabilities, allowing American policymakers to make strategic decisions based on factual assessments rather than speculative estimates. Eisenhower, recognizing the strategic value of reliable intelligence, approved the program despite concerns about the diplomatic consequences of violating Soviet airspace. The president authorized the CIA to lead the project, with the Air Force providing logistical support, pilot training infrastructure, and operational expertise. Lockheed Skunk Works received the contract to develop the aircraft in a competitive selection process that evaluated proposals from multiple aerospace manufacturers. Kelly Johnson's design stood out for its simplicity, performance potential, and rapid development timeline. Johnson promised to deliver the first operational aircraft within 8 months, an extraordinarily aggressive schedule for a program developing technology that pushed the boundaries of aerospace engineering. The Skunk Works team, operating under conditions of extreme secrecy at Lockheed's Burbank facility, designed and constructed the U-2 prototype using unconventional materials and manufacturing techniques that prioritized weight reduction and aerodynamic efficiency. The aircraft's wings, built with exceptionally thin aluminum skin supported by internal spars, were designed to flex dramatically during flight, bending upward under aerodynamic loads to maintain lift in the thin stratospheric air. The fuselage, barely wide enough to accommodate a single pilot, contained no defensive armament, no ejection seat in early models, and minimal avionics beyond essential navigation instruments. Every ounce of weight saved translated into additional altitude capability or extended mission range. The landing gear configuration, consisting of a bicycle-style arrangement with main wheels mounted fore and aft along the centerline and detachable outrigger wheels that supported the wingtips during taxi operations, minimized drag and reduced structural weight. This design required pilots to execute landings by deliberately stalling the aircraft just above the runway, allowing it to settle onto its main wheels in a controlled descent that left little margin for error. Ground crews manually installed outrigger wheels before each flight, which detached and fell away during takeoff as the wings generated sufficient lift to support the aircraft without ground contact. The first U-2 prototype completed taxi tests at Groom Lake, a remote dry lakebed in Nevada that would become known as Area 51 in the summer of 1955. Richard Bissell, the CIA officer overseeing Project AQ-A20, and Colonel Osmond Ritland, his Air Force liaison, had selected the Groom Lake site in April 1955 after surveying dozens of potential locations across the American Southwest. The site offered absolute isolation, protected airspace free from commercial aviation traffic, and a natural runway formed by the ancient lakebed's perfectly flat surface. Kelly Johnson, upon first seeing the location from the air, immediately recognized its suitability for testing an aircraft as sensitive and classified as the U-2. The CIA arranged for the Atomic Energy Commission to add the Groom Lake area to the Nevada test site, ensuring the location remained under strict security control. By July 1955, construction crews had erected hangars, workshops, housing facilities, and fuel storage infrastructure necessary to support flight testing operations. The base, which Johnson's team nicknamed Paradise Ranch in an ironic reference to its barren desert environment, became the birthplace of American reconnaissance aviation. Lockheed test pilot Tony LeVere conducted the U-2's first flight in August 1955, an unplanned event that occurred when the aircraft unexpectedly became airborne during high-speed taxi tests. LeVere, startled by the aircraft's eagerness to fly, climbed to an altitude of approximately 35 feet before settling back onto the lakebed. Subsequent test flights validated the aircraft's extraordinary altitude capability, with the U-2 reaching altitudes above 70,000 feet within weeks of initial flight testing. The camera system installed in the U-2 was as revolutionary as the aircraft itself. Developed by Edwin Land working in collaboration with optical engineer James G. Baker of Harvard University and the Perkin-Elmer Company, the aircraft's main reconnaissance camera utilized a series of ultra-high-resolution lenses capable of resolving objects smaller than 2 feet across from altitudes above 70,000 feet. The initial camera system, designated the A1, consisted of modified Heiken K38 cameras with 24-inch focal length lenses. This system, while representing a significant improvement over existing reconnaissance cameras, was quickly superseded by the A2 camera, which employed 3 modified K38 cameras with improved lenses designed personally by Baker. Baker utilized an IBM card-operated computer at Boston University to calculate the precise curvature, spacing, and light-bending properties of his lenses, then ground each lens himself to achieve unprecedented optical quality. The A2 system delivered resolution more than 3 times better than any previously available reconnaissance camera. The ultimate achievement came with the B camera, an entirely new single-lens system featuring a 36-inch focal length that took 18 by 18-inch photographs using 2 overlapping strips of 9.5-inch film that unspooled from opposite directions. Kodak developed specialized film manufactured from mylar polyester base, which offered superior dimensional stability across extreme temperature variations compared to conventional cellulose acetate film. This new film allowed the U-2 to carry single continuous strips of film measuring approximately 1 mile in length, providing capacity for nearly 4,000 individual exposures during a single mission. The B camera, weighing less than 500 pounds including film magazines, could capture details as small as 2.5 feet wide from an altitude of 60,000 feet. Film spools inside the aircraft's cube, the camera compartment located behind the cockpit, recorded continuous images during long-duration flights, capturing Soviet military installations, missile test sites, nuclear facilities, and bomber airfields with extraordinary clarity. American intelligence analysts discovered they could count individual vehicles, identify specific aircraft types, assess construction progress on missile silos, and map the exact locations of radar installations from photographs taken at altitudes the Soviets considered unreachable. The U-2's camera system delivered intelligence no satellite could provide in the late 1950s, no ground agent could collect without catastrophic risk, and no diplomatic channel could verify independently. Each mission generated thousands of linear feet of exposed film, providing the United States with photographic documentation of Soviet military infrastructure that reshaped intelligence assessments and strategic planning. The physiological demands of U-2 flight required pilots to wear specialized pressure suits that functioned as individual spacecraft life support systems. At altitudes above 63,000 feet, the atmospheric pressure drops so low that human blood and other bodily fluids would boil without artificial pressurization. The temperature at U-2 mission altitudes averaged minus 70 degrees Fahrenheit, cold enough to cause fatal hypothermia within minutes of exposure. Early U-2 pilots wore modified partial pressure suits originally developed for high-altitude bomber crews, but these proved inadequate for the extended duration missions the U-2 conducted. The Air Force and CIA developed the MC-2 full-pressure suit, later replaced by the S-1010 suit used in the U-2R variant, which weighed approximately 90 pounds and consisted of 3 layers of fire-resistant Nomex material. The suit functioned as a sealed environment that maintained internal pressure equivalent to an altitude of approximately 35,000 feet, protecting the pilot from decompression, extreme cold, and potential ejection scenarios. The helmet incorporated a coated fabric face barrier that divided oxygen supply into 2 compartments, one covering the eyes, nose, mouth, and chin, and another housing the rest of the head linked to air circulation within the suit. An exhalation valve near the right cheek allowed the pilot's breath to pass between compartments while maintaining pressure integrity. The visor contained a transparent resistive heater to prevent condensation from obscuring visibility. A feeding port in the helmet's front panel allowed pilots to consume liquid and paced food during missions lasting 8 hours or longer. Before each flight, pilots underwent a pre-breathing procedure that required breathing pure oxygen for approximately 1 hour to eliminate nitrogen from their bloodstream, preventing decompression sickness at extreme altitude. This pre-breathing occurred in specialized chambers where pilots sat in their pressure suits connected to oxygen supply systems, reviewing mission plans and conducting final equipment checks. After pre-breathing, pilots switched to portable oxygen systems that sustained them during the walk from the preparation facility to the aircraft. Once aboard the U-2, ground crews connected the pilot to the aircraft's onboard oxygen and environmental control systems, which maintained suit pressurization and breathable atmosphere throughout the mission. The pressure suit severely restricted movement, limited visibility through the helmet visor, and transformed routine tasks like adjusting instruments or changing camera settings into physically demanding efforts. Despite these challenges, U-2 pilots learned to function effectively within their suits, maintaining precise aircraft control and completing complex reconnaissance procedures while encased in what amounted to a personal spacecraft. The first operational mission over Soviet territory launched from Wiesbaden Air Base in West Germany on July 4, 1956. The CIA pilot flying under the codename Grand Slam crossed the Soviet border, flew directly over Leningrad, continued east to photograph bomber bases and shipyards near Murmansk and Arkhangelsk, then descended back through friendly airspace over Norway after a mission lasting nearly 9 hours. Soviet radar operators detected the intrusion immediately. Ground control stations reported an unidentified contact moving at an altitude radar operators initially dismissed as instrument malfunction. When multiple radar sites confirmed the same impossible altitude reading, Soviet Air Defense Command scrambled interceptor squadrons from 3 separate airfields. MiG-17 fighters climbed aggressively toward the intruder, pushing their engines to maximum thrust in attempts to reach interception altitude. At 50,000 feet, with their engines straining and airframes shuddering near structural limits, the MiG pilots reported they could climb no higher. The American reconnaissance aircraft cruised serenely above them, completely untouchable, its camera recording every frantic Soviet response. Multiple SA-2 missile batteries attempted to engage the target, firing salvos that climbed toward maximum altitude before exhausting propellant and tumbling back to Earth. The early SA-2A variant possessed a maximum effective altitude of only 22,000 meters, approximately 72,000 feet, barely adequate to engage the U-2 under ideal conditions. In practice, the missile's guidance systems struggled to track targets at extreme altitude, reducing effective engagement capability to altitudes well below theoretical maximum performance. Not a single missile reached interception range during the July 4th mission. The U-2 completed its mission without evasive maneuvers, without defensive countermeasures, and without a scratch. Soviet air defenses, constructed at enormous cost and deployed across the breadth of the USSR, proved utterly incapable of stopping a single American reconnaissance aircraft. Soviet leadership reacted with fury and disbelief. Premier Nikita Khrushchev, upon receiving briefing reports detailing the incursion, reportedly became enraged, demanding explanations from air defense commanders who had no satisfactory answers. Soviet radar data confirmed the intrusion had occurred. Photographic evidence from ground observers verified an aircraft flying at extreme altitude, yet no Soviet weapon could reach it. Khrushchev feared the political and strategic implications of American surveillance capability that Soviet defenses could not challenge. In internal Communist Party meetings, he expressed the chilling concern that, when they understand that we are defenseless against an aerial attack, it will push the Americans to begin the war earlier. The Kremlin issued immediate orders to accelerate development of higher-altitude interceptors, more capable surface-to-air missiles, and advanced radar systems designed to track and engage stratospheric targets. Soviet engineers scrambled to redesign missile propulsion systems, improve radar sensitivity, and develop interceptor aircraft capable of sustained flight above 65,000 feet. The Almaz Design Bureau, responsible for the SA-2 system, began work on improved variants with enhanced propulsion stages that would extend maximum engagement altitude. The SA-2B variant, introduced in the late 1950s, achieved a maximum effective altitude of 30,000 meters, approximately 98,000 feet in theory, though actual combat performance remained significantly lower. Even with these improvements, Soviet missile systems struggled to engage targets at the extreme altitudes where the U-2 operated. The entire Soviet air defense establishment entered a period of frantic modernization, driven by the humiliating realization that American reconnaissance aircraft could violate Soviet airspace at will. The U-2 missions continued relentlessly. Between 1956 and 1960, the CIA conducted more than 20 overflights of the Soviet Union, photographing missile test ranges, nuclear reactor facilities, bomber production complexes, submarine shipyards, and strategic command installations. Operational U-2s deployed to forward bases in Turkey, Pakistan, Norway, and Taiwan, creating a network of launch sites that allowed reconnaissance missions to penetrate Soviet airspace from multiple directions. Incirlik Air Base in Turkey hosted U-2 operations targeting Soviet facilities in the southern USSR and Middle Eastern regions. Peshawar Air Base in Pakistan provided access to Soviet Central Asia, missile test ranges, and the Chiratam Cosmodrome where Soviet space and ballistic missile programs conducted launch operations. Bodo Air Base in Norway served as a recovery site for missions that transited across the Soviet Union from south to north, allowing single flights to photograph thousands of miles of Soviet territory. These geographically dispersed operating locations complicated Soviet air defense planning, forcing the USSR to maintain alert interceptor squadrons and missile batteries across its entire territory rather than concentrating defenses around specific high-value targets. Each mission generated thousands of frames of high-resolution intelligence imagery that American analysts studied in exhaustive detail at secure CIA facilities. U-2 photographs revealed the true scale of Soviet strategic bomber production, exposing inflated claims of Soviet air superiority as propaganda. Images of Soviet missile test facilities allowed American intelligence to track the development of intercontinental ballistic missiles, assess payload capacities, and estimate deployment timelines. Reconnaissance photographs of Soviet nuclear test sites documented weapon yields, delivery system development, and the pace of Soviet nuclear expansion. This intelligence fundamentally reshaped American understanding of Soviet military capabilities, allowing the Eisenhower administration to counter Soviet propaganda claims with factual assessments derived from photographic evidence. The U-2 also flew missions over China, documenting the construction of nuclear facilities and missile complexes that revealed Beijing's emerging strategic weapons program. Flights over the Middle East provided critical intelligence on Soviet arms shipments to Egypt and Syria during periods of heightened regional tension. The U-2 became the single most important intelligence collection platform in the American arsenal, delivering strategic information that no other source could provide. Soviet efforts to intercept U-2 flights grew increasingly desperate. Air Defense Command ordered interceptor squadrons to scramble at the first indication of high-altitude intrusion, directing pilots to push their aircraft to absolute operational limits. MiG-19 fighters, capable of reaching altitudes near 60,000 feet in brief zoom climbs, attempted vertical interceptions where pilots would climb steeply, fire unguided rockets toward the estimated position of the U-2, then descend rapidly before their engines flamed out in the thin air. These attempts failed consistently. The U-2 flew too high, moved too unpredictably, and disappeared from radar coverage before interceptors could close engagement range. Soviet SA-2 missile batteries received upgraded guidance systems and more powerful rocket motors designed to extend maximum engagement altitude. Launch crews drilled relentlessly on rapid engagement procedures, attempting to fire salvos before the U-2 could escape radar lock. Despite these improvements, most missile launches failed to achieve intercept altitude, and those that climbed high enough lacked the guidance precision to engage a target moving at stratospheric altitude. The SA-2's proximity fuse, designed to detonate the warhead when passing near a target, proved insufficiently sensitive at extreme altitudes where the thin atmosphere reduced blast effectiveness. The warhead, weighing 195 kilograms and packed with high explosive fragmentation material, possessed a blast radius that varied dramatically with altitude. At the high altitudes where U-2s operated, the blast radius could theoretically reach 244 meters, but the reduced atmospheric density meant fragments dispersed with less energy and over wider areas, significantly reducing lethality. Soviet radar operators grew increasingly frustrated as they tracked American reconnaissance aircraft crossing Soviet territory with impunity, helpless to prevent the violations. Internal Soviet air defense reports from this period document a sense of profound inadequacy among personnel who understood their systems were technologically outmatched. The technical demands of U-2 flight required extraordinary pilot skill. Operating at 70,000 feet placed the aircraft in an aerodynamic regime where the margin between stalling speed and maximum structural speed measured less than 10 knots. Pilots navigated this coffin corner for hours, maintaining precise airspeed control while managing fuel consumption, operating camera systems, and navigating over featureless terrain using celestial navigation techniques derived from bomber operations. The Pratt& Whitney J57 engine, operating in air so thin that combustion barely sustained itself, required constant monitoring and delicate throttle inputs. Engine flameouts occurred frequently when fuel flow, air density, or throttle adjustments upset the precarious combustion balance. When flameouts occurred, pilots executed restart procedures while descending rapidly through hostile airspace, attempting to reach denser air where the engine could reignite before losing so much altitude that Soviet interceptors could engage. Navigation presented equally demanding challenges. Flying over the Soviet Union for 8 hours with minimal navigation aids required pilots to use sextants, similar to those employed by maritime navigators, to determine position by measuring angles to celestial bodies. These celestial fixes, combined with dead reckoning based on airspeed and heading, allowed pilots to maintain flight paths that passed over designated reconnaissance targets despite flying through airspace, where radio navigation beacons were unavailable or deliberately jammed by Soviet electronic warfare systems. Camera operation added another layer of complexity. Pilots activated camera systems at precise waypoints, adjusted exposure settings based on lighting conditions and cloud cover, and monitored film consumption to ensure adequate capacity remained for subsequent targets along the flight plan. All of these tasks occurred while wearing the restrictive pressure suit that limited visibility, constrained movement, and made even simple actions like reading instrument panels or adjusting switches physically taxing. Despite these challenges, U-2 pilots completed mission after mission with remarkable success. Their professionalism, technical expertise, and willingness to fly deep into Soviet territory knowing interception meant certain capture or death exemplified the human dimension of Cold War intelligence operations. The strategic implications of U-2 reconnaissance extended far beyond military intelligence. The aircraft's ability to photograph Soviet territory with impunity undermined Soviet diplomatic posturing, exposed exaggerations of Soviet military strength, and allowed American policymakers to counter Kremlin threats with factual assessments of Soviet capabilities. During diplomatic negotiations over arms control, disarmament, and regional conflicts, American negotiators possessed intelligence advantages that Soviet counterparts could not match. The United States knew the exact number of Soviet intercontinental bombers, understood the locations of Soviet missile test facilities, and possessed photographic documentation of Soviet nuclear infrastructure. This asymmetry in intelligence capability shifted the strategic balance of the Cold War, enabling American decision-makers to formulate policies grounded in empirical data rather than speculative assessments. The U-2 also provided critical warning intelligence that allowed the United States to monitor Soviet military developments in real time, reducing the risk of strategic surprise and enabling proactive responses to emerging threats. Every U-2 mission reinforced American technological superiority, demonstrated Soviet vulnerability, and reminded the Kremlin that the United States possessed capabilities the USSR could not counter. The psychological impact on Soviet leadership cannot be overstated. Soviet military planners understood that if American reconnaissance aircraft could photograph Soviet installations with impunity, American bombers carrying nuclear weapons could potentially do the same, exploiting the same altitude advantage to evade Soviet air defenses. This vulnerability drove Soviet investments in improved interceptors, advanced surface-to-air missiles, and eventually intercontinental ballistic missiles that could bypass air defenses entirely by operating in space. If you appreciate discovering Cold War secrets hidden for decades, consider subscribing for future declassified revelations. Soviet frustration reached a breaking point on May 1, 1960, when a U-2 piloted by CIA contractor Francis Gary Powers was shot down over Sverdlovsk in the Ural Mountains. The aircraft, flying a reconnaissance mission photographing Soviet ICBM facilities, departed from Peshawar Air Base in Pakistan on a planned flight path that would cross Afghanistan, overfly Soviet missile test sites and nuclear facilities, then continue north across the industrial heartland before recovering at Bodo, Norway. The mission covered approximately 3,800 miles of Soviet territory, representing one of the most ambitious reconnaissance flights ever attempted. Soviet radar systems tracked Powers from the moment his aircraft entered Soviet airspace over Afghanistan. Premier Khrushchev received a telephone call from Defense Minister Marshal Rodion Malinovsky at 5 o'clock in the morning informing him of the intrusion. Soviet Air Defense Command scrambled interceptors and alerted SA-2 missile batteries along the projected flight path. A Soviet Su-9 interceptor launched from Sverdlovsk airfield and climbed toward interception altitude but failed to achieve visual contact with the target. Soviet Air Defense Commander Marshal Sergei Biryuzov, coordinating the response from his command center, informed Khrushchev that missile batteries near Sverdlovsk represented the best opportunity for engagement. As powers approached Sverdlovsk, multiple SA-2 batteries launched salvos toward his aircraft. One missile detonated close enough to cause catastrophic damage, destroying the U-2's tail section and sending the aircraft into an uncontrollable descent. Powers managed to eject successfully and was captured by Soviet authorities shortly after landing by parachute. The incident became an international crisis. Khrushchev publicly revealed the shootdown at a Supreme Soviet meeting, displayed wreckage of the aircraft, and paraded Powers before international media, exposing the American Reconnaissance program and derailing a planned summit meeting between Eisenhower and Khrushchev scheduled in Paris. American officials initially denied the existence of the Reconnaissance program, issuing statements claiming the aircraft was a NASA weather research plane that had strayed off course due to oxygen system malfunction. When Soviet authorities presented Powers' identifiable wreckage, including the sophisticated camera system and undeveloped film recovered from the crash site, the cover story collapsed entirely. The incident humiliated the Eisenhower administration, strained relations with Pakistan and other nations hosting U-2 operations, and ended CIA overflights of the Soviet Union. Yet the shootdown did not diminish the strategic impact of the U-2 program. Between 1956 and 1960, American U-2 missions collected intelligence that reshaped Cold War strategy, exposed Soviet military vulnerabilities, and provided policymakers with information the USSR desperately sought to conceal. Even after the Powers incident, the U-2 continued flying reconnaissance missions in regions beyond Soviet airspace. During the Cuban Missile Crisis in October 1962, U-2 aircraft photographed Soviet ballistic missile installations under construction in Cuba, providing President Kennedy with undeniable evidence of Soviet strategic deception. Major Richard Haser, flying a U-2 from Laughlin Air Force Base in Texas, captured the first photographs of Soviet missile sites in Cuba on October 14, 1962. The imagery revealed medium-range ballistic missile installations in various stages of construction, complete with erector launchers, missile transporters, and support equipment identical to systems deployed in the Soviet Union. Intelligence analysts compared the Cuban photographs to imagery collected during previous U-2 missions over Soviet territory, positively identifying the missile systems and estimating deployment timelines. These photographs became the foundation for Kennedy's decision to impose a naval blockade on Cuba and demand immediate removal of Soviet missiles. The U-2 imagery was so detailed that analysts could measure the dimensions of missile components, identify specific vehicle types, and assess construction progress with precision that left no room for Soviet denials. Major Rudolf Anderson, flying a U-2 reconnaissance mission over Cuba on October 27, 1962, was shot down by a Soviet SA-2 missile operated by Soviet personnel deployed to Cuba as part of the missile installation effort. Anderson's death, the only U-2 combat loss during the Cuban Missile Crisis, underscored the lethal risks U-2 pilots accepted in pursuit of intelligence critical to national security. His sacrifice occurred during the most dangerous moment of the crisis, when tensions between the United States and Soviet Union brought the world to the brink of nuclear war. The Cuban Missile Crisis demonstrated that even a decade after its first flight, the U-2 remained an indispensable intelligence asset capable of delivering photographic evidence that reshaped presidential decision-making and prevented catastrophic miscalculation. The U-2 also flew extensive missions over China, Southeast Asia, and other regions where American intelligence sought photographic documentation of military developments. Flights over China in the late 1950s and early 1960s, operating from bases in Taiwan, documented the construction of nuclear weapon facilities at Lop Nur, missile test ranges, and bomber production complexes, providing American analysts with critical insights into Chinese strategic capabilities during a period when China remained almost entirely closed to Western observation. Several U-2s operated by Republic of China Air Force pilots under CIA direction were lost over China to surface-to-air missiles as Chinese air defenses adopted Soviet SA-2 technology and tactics. U-2 missions over Vietnam during the early years of American involvement in Southeast Asia tracked North Vietnamese troop movements, supply routes along the Ho Chi Minh Trail, and anti-aircraft installations, generating intelligence that shaped operational planning and targeting decisions. The aircraft's long-range endurance, high-altitude capability, and advanced camera systems made it uniquely suited for missions where satellite reconnaissance remained unavailable or insufficient. As satellite technology matured in the 1960s and 1970s with programs like Corona and later KH-series reconnaissance satellites, the U-2's role shifted from strategic reconnaissance over denied territory to tactical intelligence support for military operations, battlefield surveillance, and signals intelligence collection. The aircraft underwent continuous upgrades, receiving improved sensors including the Senior Year Electro-Optical Reconnaissance System, advanced synthetic aperture radar systems, and signals intelligence packages that transformed the U-2 from a pure photographic reconnaissance platform into a multi-sensor intelligence collector capable of gathering imagery, electronic emissions, and communications intelligence simultaneously. Soviet responses to the U-2 program accelerated development of high-altitude interceptors and surface-to-air missile systems that reshaped Soviet air defense architecture for decades. The MiG-25 Foxbat, designed specifically to intercept high-altitude reconnaissance aircraft including the U-2 and the even faster SR-71 Blackbird, entered service in the late 1960s with performance capabilities that included sustained flight above 70,000 feet and dash speeds exceeding Mach 2.8. The SA-2 missile system received successive upgrades through the 1960s and 1970s, with the SA-2F variant achieving a maximum effective altitude of 55,000 meters and improved guidance systems that enhanced tracking accuracy against high-altitude targets. Soviet radar networks expanded dramatically, integrating early warning radars, height-finding radars capable of accurately determining target altitude, and tracking radars that provided continuous target data to missile guidance systems. These developments, driven directly by the humiliation of American U-2 overflights, transformed Soviet air defenses into one of the most formidable integrated air defense systems in the world, a layered network that would challenge American air operations for decades during conflicts in Vietnam, the Middle East, and the Balkans. Yet the strategic damage to Soviet prestige and the intelligence advantage gained by the United States during the critical years of 1956 to 1960 had already occurred. The United States collected intelligence that exposed Soviet military weaknesses, verified American technological superiority, and provided policymakers with information that shaped Cold War strategy through the 1960s and beyond. The U-2 Dragon Lady proved that altitude could serve as an effective shield against interception during the critical opening years of strategic reconnaissance. By operating in a flight regime Soviet defenses could not reach, American reconnaissance aircraft collected intelligence the USSR desperately sought to protect. The program demonstrated that strategic advantage in the Cold War depended not only on military hardware, but on intelligence capabilities that enabled informed decision-making. The U-2 transformed American understanding of Soviet military capabilities, exposed Soviet propaganda claims as exaggerations, and provided policymakers with photographic evidence that reshaped diplomatic negotiations and strategic planning. The aircraft's success validated the vision of leaders like President Eisenhower, who understood that intelligence collection represented a critical component of national security, and engineers like Kelly Johnson, who possessed the brilliance to design machines that defied contemporary engineering assumptions. Soviet commanders entered the mid-1950s confident their air defenses could repel any American intrusion. The U-2 shattered that confidence, flying mission after mission over Soviet territory, while Soviet interceptors and missiles failed to reach interception altitude. The humiliation drove Soviet military modernization, accelerated development of advanced air defense systems, and reinforced the Kremlin's understanding that technological superiority determined strategic outcomes. Yet by the time Soviet defenses finally achieved the capability to shoot down a U-2 in May 1960, American intelligence had already collected the information it needed. The United States understood the true scale of Soviet military capabilities, possessed photographic documentation of Soviet strategic infrastructure, and held intelligence advantages that shaped Cold War strategy for decades. The U-2 reconnaissance program represented one of the most successful intelligence operations in American history, demonstrating the power of technological innovation, the value of strategic intelligence collection, and the consequences of underestimating American aerospace capabilities. Soviet leaders dismissed early American reconnaissance efforts as futile gestures that Soviet air defenses would easily defeat. Instead, they watched in frustration as American aircraft photographed their most closely guarded secrets from altitudes their weapons could not reach. The U-2 proved that in the Cold War's contest of technological and intelligence capabilities, the nation that could see furthest held the decisive advantage. Join us here at Classified Warfare as we uncover the operations and technologies that kept the world on the brink.